The Masses and Springs simulation is an interactive educational tool designed to help students explore and understand the principles of oscillatory motion in mass spring systems. By providing a hands-on approach to investigating the factors that affect the period of oscillation, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics. The simulation allows students to play with one or two mass spring systems, adjust various parameters, and observe the effects on the system's behavior. Additionally, students can view the net force or component forces, explore how velocity and acceleration change throughout the oscillation, and investigate the energy in the system in real time. The simulation also enables students to collect data and determine the value of a mystery mass, or the gravitational acceleration, on a hypothetical planet X. A mass spring system is a fundamental model for understanding oscillatory motion, where a mass is attached to a spring and oscillates back and forth. The Masses and Springs simulation begins by introducing the concept of oscillatory motion, explaining how the mass spring system behaves under the influence of restoring and gravitational forces. The simulation provides an interactive platform where students can actively engage with the concept of mass spring systems. By adjusting various parameters, such as mass, gravity, spring constant, and spring length, students can observe how these factors affect the period of oscillation. This hands-on approach helps students gain a deeper understanding of the principles governing oscillatory motion. The Masses and Springs simulation allows students to investigate which variables affect the period of oscillation. The period of a mass spring system is the time it takes to complete one full cycle of oscillation. By adjusting the mass, gravity, spring constant, and spring length, students can observe how these factors affect the period. Increasing the mass of the oscillating object increases the period of oscillation. Changing the gravitational acceleration affects the period, especially in vertical oscillations where gravity plays a significant role. The spring constant determines the stiffness of the spring. A higher spring constant results in a shorter period of oscillation. The natural length of the spring affects the equilibrium position, but does not directly affect the period of oscillation. The simulation allows students to view the net force or component forces acting on the mass spring system. The net force is the resultant force acting on the mass, which is the sum of the restoring force provided by the spring and the gravitational force. By observing the forces in the system, students can gain a deeper understanding of the dynamics of oscillatory motion. Students can also explore how the velocity and acceleration change throughout the oscillation. By observing these quantities, students can understand the relationship between force, acceleration, and velocity in oscillatory motion. For example, they can see that the velocity is maximum at the equilibrium position and minimum at the extreme positions, while the simulation allows students to explore the energy in the system in real time. As the mass spring system oscillates, its energy is continuously converted between potential energy, stored in the spring, and kinetic energy, energy of motion. At the extreme positions, the system has maximum potential energy and minimum kinetic energy. At the equilibrium position, the system has maximum kinetic energy and minimum potential energy. By observing the energy in the system, students can discover the conservation of mechanical energy. The total mechanical energy of the mass spring system, which is the sum of its potential and kinetic energy, remains constant throughout the oscillation. This principle of energy conservation is a fundamental concept in physics and helps students understand the interplay between different forms of energy. The simulation allows students to collect data and determine the value of a mystery mass. By adjusting the parameters of the system and observing the period of oscillation, students can use the formula for the period of a mass spring system. Students can also explore the gravitational acceleration on a hypothetical planet X. By adjusting the gravitational force in the simulation and observing the period of oscillation, students can determine the value of the gravitational acceleration on planet X. This feature helps students understand the relationship between gravity and oscillatory motion and apply their knowledge to solve real-world problems. The simulation provides an interactive platform where students can actively engage with the concepts of mass spring systems. By adjusting various parameters and observing the results, students can gain a deeper understanding of the principles governing oscillatory motion. The The visual nature of the simulation makes abstract concepts more tangible. Students can observe the oscillation, forces, velocity, acceleration, and energy in the system in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The masses and springs simulation is a valuable tool for teaching and learning about the principles of oscillatory motion in mass spring systems. By providing an interactive, visual, and comprehensive platform, it helps students understand the factors that affect the period of oscillation, such as mass, gravity, spring constant, and spring length. The simulation allows students to view the net force or component forces, explore how velocity and acceleration change throughout the oscillation, and investigate the energy in the system in real time. Additionally, students can collect data and determine the value of a mystery mass, or the gravitational acceleration, on a hypothetical planet X. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of oscillatory motion and its applications in various scientific and engineering fields.